For Unit 8, you're talking about inverses of functions, but in order to have an inverse, a set of data must actually represent a function. So let's functions and function notation. All right, back on this slide. What is a function? Okay, that's like any equation you've ever graphed before. Okay, but we've never really noticed that it's each x, it only maps or gives one y value. Okay, so they have to be unique. It can't, if you plug in x is 2 to an equation, 2 can't come out as 4 and as 7. Now an inverse means each x and y are uniquely matched. Let's look at an example here. So like if I had some kind of function, and here's my table for it, here's x and y. 2 could go to 4, 3 could go to 7, 5 could go to 4. And you might say, I thought they couldn't map to the same y. It's okay if this x goes to 4 and this x goes to 4. They're just not unique. Now over here, that would not be possible. So if we have a function and an inverse, we could say 4 goes to 2 and 7 goes to 3, but we'd have to have another number, say like 9 go to 5. We can't, these are all unique. There's no doubling up on the x's and y's over there. It might also be helpful when it comes to being a function, and again, this is kind of a Math 2 topic, but just think about what's not a function. So I would put an xy table here and say 2 goes to 4, 3 goes to 7, 5 goes to 4. We know that's okay. But if I put 2 to 7 here, or to any number really, even if it was 8, this 2 is going to 8, and this 2 is going to 4. When you put 2 into the function, it can't confuse you and give you 2 different numbers. So that would not be a function because each x doesn't only map to one y value. That certain x is mapping to 2 different y values. So that would not be a function. This would be a function. Remember, still okay for different x's to go to the same y value, but not the same x value to go to different y values. Again, to be an inverse, all of these have to be unique. 4 can only go to 2, and 2 can come from 4. That's how we know it has an inverse. Also, one thing, the x's and y's switch on inverses. So, for example, if I had a table where you said, hey, 2 goes to 3, and 7 goes to 4, and 8 goes to 1, and this is on the function, then its inverse would be 3 goes to 2, 4 goes to 7, and 1 goes to 8. They don't have to be in that order, but the x's and y should switch if they're inverses. Now, when it comes to graphing functions, you've been graphing functions for a long time, and this is just about functions. If you have a function like x squared, something like that, that is definitely a function. We also could have a function like this. That is still a function. Even functions like our fun rational polynomials. Okay. These are all functions, and basically everything you've worked with in math has been functions. Now, let's talk about something called the vertical line test. If I were to take and make a dashed line, get black here, and draw it down here. If you take a vertical line and drag it across a graphed function like this, it should never cross that line twice. So see how I'm going? That black line is only hitting the red function one point at a time. This one too. As you go through, it's only hitting that line one point at a time. Also over here. Now, I kind of thought that should be an asymptote here, but this one technically should be a function as long as there's asymptotes right there. If you only hit the graph one time with a vertical line test, we say it's a function. Okay. Now, another thing we need to know about, if it has an inverse, remember an inverse has to be 1 to 1. So if I would draw a horizontal line and drag that up and down across the function, this one actually is not going to have an inverse because, oops, sorry. As I drag it down here, you can see that this horizontal line hits that function 3 times as I go across that set value here. So 1, 2, 3. This function would not have an inverse. It's still a function because it passes the vertical line test, but it's not an inverse function. Not going to have an inverse because it does not pass the horizontal line test. This parabola also fails the horizontal line test. For example, plug in 3, I would get 9. Plug in -3, I get 9. That is unique. Therefore, it does not have an inverse. Now, we'll talk about this more a little bit later, but you could have someone say, well, let's just look at this part of the graph. It's called restricting the domain. If you only look at graph when it's greater than or equal to 0, then yes, we do try to find inverses still. So, it must pass a vertical line test to be a function, and it must pass the horizontal line test to have an inverse.